What's going on, everyone? Welcome to our very first Rhinoceros 3D tutorial, also called Rhino for short. And today we're going to be working specifically with Rhinoceros 6. So Rhino is one of my favorite programs. I've learned it while I was in architecture school, and it's an excellent, one of the best actually modeling softwares that I've used personally. And there's so many things that you can do. Possibilities are almost endless, from different coding scripts you can do, complex models, to even beautiful renderings. So because there's so many things that you can do with this program, and I'm going to share with you 7 steps that you need to get started on Rhino. And these are just fundamentals. So let's get right into it. Just to reiterate, I have Rhino 6 operating right now, and this is the basic layout. You have your top view, looking at everything from the top, looking at perspective, front and right, and you can always toggle that and change it as well. This is just incredible. I love this program. You can really tell from my excitement. So the first tool that we're gonna go over is basic line. To activate the line tool, we just click Polyline here. And let's zoom into our top viewport, and you can literally draw any shape. Let's just turn off our ortho by hitting F8 on the keyboard. And let's just do something weird. And you can hit C to close, or just go to the endpoint. C, enter. So you can draw all types of shapes, curves, using the line tool, PL, which is Polyline, or just using the line tool itself. There's different types of line segments that you can make by holding and clicking and going through this tab, flyout tab. And there's even curved lines that you can do. So this Polyline, click and have like a series of nodes to create curved shape, or even something like this where you can control the nodes and click, 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 click to create your geometry. So what's incredible about this is that these lines, as you can see, let's go to our perspective, is flat. And I just want to express this. If you're an architectural student, this is a must-know program. A lot of firms are actually starting to look to see if you do have experiences aside from Revit and AutoCAD. You can even use this program if you're a jewelry designer, or someone that makes models, or someone that 3D prints things. Is for all kinds of professions. So I definitely recommend watching this video. Going back to our perspective view, you can see that this object is basically flat, what we made. But if we highlight them and hit EXT R, you'll see a command called Extrude Curve. And if you don't see it, you can just type it up. If we hit enter, we're able to extrude it. And this is what's going to give 3-dimensionality to our objects. Any object you can think of drawing, right? So let's highlight this, and actually let's change the mode to shaded. If you click on this flyout tab, you can change the display mode so you can see it in different ways. This is ghosted, so you can see through it. Shaded is more solid, you can't see through it. And then you have Arctic and many other types of views with Rhino 6. It's incredible. So let's stick to shaded. Once you make these extruded volumes, what you want to do to make it a closed poly surface is highlight it, and hit cap. And this is going to enclose the object. And because there are so many things you can do with these extruded volumes, I'm going to save this for a future video. One thing I have to note, however, in order to extrude something, it needs to be a planar surface. What that means is that the line that you're extruding must literally be flat. How do you know if something's planar? So let's go to this view, and by looking here from the front view, we can see that the lines that we drew, these shapes, it's actually flat. So if the thing is curving in the front or the right or the back profile, that means it's a non-planar surface, and therefore when you extrude it, you won't be able to cap the object. But there's always different, techniques that you can use to cap it, which I will also go over in a future video. So another way to extrude an object, which is super cool, is to highlight both, hit COPY for copy. And what the vertical command means is, do you want to copy it vertically? Because if I don't copy it vertically, right, and I just hit enter, it's going to go in any sort of direction, right? Or if I do it from the top view, it's only going to go left, right, or any sort of direction. But when I'm in perspective view or front view, but more specifically perspective view, if I hit copy, V, enter to make it vertical, yes, it's only going to go in the vertical axis. So what we're going to do is we're going to make a copy here. What we want to do is highlight it, hit loft, and what lofting does is that it creates an extruded volume using 2 or more segments. So you must have like similar reference points, have the arrows going in the same direction. You can click to change the direction of the arrows. And what we do is that we hit enter. You can always modify the surfaces or rebuild it to make it more tighter, more accurate. And then once we have this surface, we can hit cap because it's a planar surface. Sorry about that. We can hit cap to enclose it. This leads us to step number 2, corner snapping. When working with programs with 3-dimensional spaces, sometimes when you want to stack objects on top of each other, it might not always be too accurate. If you ever try to do this on a program like AutoCAD 3D, you'll know exactly what I'm talking about. It's so stressful. You think 2 objects are meeting, but then one's all the way across in space. Fortunately, Rhino has something called O-snap. So O-snap, basically by turning this on, you have access to have all these different types of connections. You can connect it through the endpoint, nearest point, any point that you add on your surface, or the midpoint, or the perpendicular axis. And let me show you what I'm talking about. So we're gonna click this box tool, and you just have to click, drag, bring it up to create a shape. And let's make a second one. So now if I click on this, hit M, enter for moving. Now we can bring it to any corner, and you see it says near. That's because we have near activated. And here it says endpoint because we have endpoint activated. Now I can attach it exactly where I want it to be. And if we orbit by right clicking, we can see it's specifically where we want it to be rather than being somewhere else in the 3D space. Let's actually copy this. Let's copy this along. Okay. It's similar to programs such as Illustrator and Photoshop. With Rhino, you also have layers. So by clicking here, we can always click the new layer button, and we can change the color of the layer so that all objects on that layer appears to be that color. And let's copy this. Let's copy maybe just the top one, right click, change object layers, or you can also copy it to the layer just to make a duplicate. So now we have it on a different layer. Let's say you want to hide something here and you want to hide everything on this layer. You're able to do that instead of manually clicking on the thing and having to hit hide. You can just turn off the layer. That leads us to the third tool, and that is a command called move face and move edge. So let's say I drew this volume, but this is not quite the height I want it to be. Let's say I wanted it to be half the height. Do I have to redraw it now? Not so. And there's many ways to do this, but this is one of the quickest and easiest way to do it. You type move face, and you just have to select the faces you want to move. So we're gonna select the top face because we want to bring this down, hit enter, bring it down, and we're gonna have it snap to the midpoint. Make sure you have midpoint turned on over here. Snap to the midpoint, and now we have it at half that height. I mean, you can also do this for any direction, any face. So we could hit this face and we could drag it back like this. That way you don't have to redraw the volume. You can just begin to tweak it and edit it any which way that you want. Let's do that again. Let's move this up. And move edge is similar to move face, except it's going to be focused on an edge. So let's type in move edge, and let's click this edge. Let's say we want this to begin to ramp downwards. So by clicking this edge, the edges that we want to move, we hit enter, we bring it down, bring it down, bring it down. Let's say right about here, and now we have something that's like a ramp. And you can always bring it back. Let's actually turn on direction constraints and let's put it to vertical. And if we go back to, if we change views, let's go to the right view. Ortho, we can always bring it back. So pretty cool, right? The next thing you all need to know is basic transformation inputs. This includes scale, rotating, rotate 2D, rotate 3D, copying, and all these things. So let's start with copying. Let's say I have a unit. Let's say this is an apartment unit. We could delete this piece. Let's say this is an apartment unit. And we want this to be several stories tall. So all you really have to do is copy it by hitting COPY and remember V enter. But I'm going to show you something really cool in just a second. So let's copy it. We use this as a reference plane. But let's say I need like 30 of these. Do I want to keep doing this again and again and again? No way. You don't have to do that. All you have to do is hit F enter. That's from last point. F enter. U enter to use the same distance that we used for the initial copy. So F enter, U enter, and then S enter in order to confirm that you want it to be in the same direction. So make sure that's toggled to yes, right? If it's no, make sure you hit S enter on your keyboard. And all you have to do is hold, click, 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 click. And this will save you a ton of time rather than having to copy it manually every single time. So the next transformation tool, let's undo this. The next transformation tool we're going to talk about is scale. So there's many ways to go about doing scale. So you can select everything. I could even go to my top view and do this. You can hit scale, and you can just make this as big or as small as you want, right? Let's say I want this side specifically to be 1 feet. What I would do is hit scale, click one edge, click that edge because I want this the total distance of this edge to be 1 feet, and hit 1 feet on my keyboard. And then this is how we do it. And then now this is 1 feet. If you measure it by hitting distance, so we measure this, we have it. But you see, it's in millimeters. And here in the US, we're the only one that use feet instead of the basic metric system. So in order to change this, which is actually the next step, we go to our command bar, type units, and then we're going to change millimeters down to feet. And then from decimal, in order to get our typical fractions, we will do feet and inches. And here you can increase the precision. So it basically, the precision is important if you want to do something very detailed and you want to make it very precise. This is very important, especially if you're working with small objects. You're going to 3D print something. You want to have a high precision. I'm just going to go on 1/8 and leave it there and hit OK. So now it's going to scale it from millimeters to foot. And now we have this. So Z enter, draw your window and zoom in. Let's click here and let's zoom in. So let's actually bring this above the C plane. So M enter, V enter. So 0, 0, 0. And now we're above the C plane. So that's one way to scale it. So there's another tool called Scale 1D, which scales the object in one particular direction. So let's highlight it and click Scale 1D. And let's choose a base point. This is my base point and this is my reference point. And now we stretch it. And that way the object will be scaled in one direction. Everything else that's being selected is going to scale as well in both direction. But if I select that object by itself, it's going to just scale by itself in one direction. So be mindful that if you select something in a group or do a group selection, the other objects might be scaled in both directions. Scale 2D. So when we do scale 2D, we select our objects. This is my first point, that's my second point, and everything is going to scale away from the point in this direction, just like that. Another transformation tool is rotate. So if we go to the top view and click rotate right here, so now we click our base point and we select the edge about which we want the object to rotate. So we'll do it right here. We can also rotate objects three-dimensionally. So let's highlight everything and go to the command bar and type rotate 3D. So you pick the axis about which you want the object to rotate, then you pick the direction you want the object to pick up. So this is the rotating axis or hinge, and this is the axis about which the object is going in. So if we go to the command bar, hit copy yes, and put 45 degrees, 90 degrees. Let's do it again, 135 degrees, and again, 180 degrees. You start to get this pattern, and you can create a lot of interesting patterns like that. So let's undo that. But these are some basic transformation tools to get you started with this program and help you do a lot of interesting geometries and offset it and place it in very compelling ways. So the next step that we're going to do is the Boolean command. The Boolean command we can find by clicking the flyout tab here, and there's a variety of different Boolean commands, which we're going to go through each of them. There's Boolean union, Boolean difference, Boolean intersection, and Boolean split. Let's start off with Boolean union. So let's say we want these two geometries to become one object. So let's go to our properties tab, and you can see it here, one closed polysurface. So let's go back to layers and undo this. And now let's say I wanted to subtract a volume from this shape beneath. Let's make some copies of this red box. So let's copy it down. Let's use scale 1D to change the size. And let's bring it to about there. And now let's make a few copies of it. So we're going to hit copy, V enter. Let's bring it there, there. Perfect. So now we have this. So what we want to do is click the flyout tab, click Boolean difference. The first step is to select the poly surface where you want to subtract from. So it'll be this one, and we hit enter. And next we have to select one or more surfaces that we want to subtract with. So we're going to select this group of surfaces, hit enter, and here we go, it's done. And if you don't want to have the cutting surfaces remain there, all you have to do is change the toggle when inputting the command. Let me show you. So right when you see this command, delete input, just change the toggle to yes if you want it to be deleted. Otherwise, if you don't want it to be deleted, just leave it as no or toggle it to no. And hit enter, and now we have a divided surface. So now you can begin to imagine all the cool and intricate things that you can do with just Boolean. So now let's move on to Boolean intersection. So Boolean intersection is going to subtract everything except the areas where both objects are intersecting. So let me change the display mode for you to see this. So right here, you can see that these are the areas where it overlaps. So this is going to be what remains. So let's select the first set of poly surface that we want to subtract, hit enter, select the second set of poly surfaces, hit enter, and here we have it. So with Boolean split, first things first, we have to highlight everything, all these red surfaces. And what we're going to do is use scale 1 2D, or actually we can use this command called stretch. So we select a base point, click at the end point, and now we stretch it all the way through. The thing is with Boolean split is that the surfaces that are being cut, which is surfaces 1 and 2, the cutting surfaces has to pass all the way through both of these surfaces in order for it to work. So let's go on Boolean split. Let's select the objects that we want to split, hit enter, and now let's select the cutting surfaces, which is each of these surfaces. And everything's divided. So my thing made a duplicate, which might happen on your Rhino. I have to fix the settings. We just have to hit delete. And we can also delete these surfaces. And now look, everything's divided. If I wanted to, I could hit delete, delete this one, delete that one, delete, delete, delete. And we have a very interesting geometry. Another great way to rotate and transform your object is actually the gumball tool. So gumball can be toggled on and off by clicking gumball on the bottom of your ribbon tab and highlight everything, and you're going to see this. So you can drag it in the Y direction, in the X direction, the X direction here, or even the Z direction up and down. It also makes for a good rotating tool. So you could go here, you can just select the blue area and begin to turn it along this axis, turn it along that axis, or even turn it along this axis. It's another fast and simple tool that you can use aside from using rotate 3D or the 2D rotate command. So let's undo all of this. There's actually another cool thing I want to show you about the Boolean difference is that you can make void a piece of the object inside. What do I mean by this? So let's go on, let's make a circle. And what we'll do is make sure it's in the center. So now we're going to extrude it. Boom. Let's hit cap. Now let's go on Boolean, Boolean difference, enter, and click that, enter. And we can see here, now it's split inside, which is really cool. And you can see it more so like this. Let's use a line. Let's click here, from going from this end to that end. And now we can select this line and actually extrude it. We want to make sure the line, when we're about to split an object, make sure it's passing completely through the object. So going beyond the surface is something I do to make sure it's accurate and it's actually going to cut through the object. So we just drag this down using the Z axis on the gumball tool, and we can just begin to expand it a bit by dragging the end point of the X axis. So when you're working with a flat planar surface, Boolean split is not going to work, unfortunately. What you have to just do is use the split command. So let's select the object we want to split and type in split. And now you just have to select the cutting objects, which is this surface, hit enter, and now it will split. We can delete this, and now let's drag this apart. And you can see what we made. So the last thing I wanted to show you is a command called make 2D. The beauty of a program like Rhino is that Rhino is compatible with so many programs: Photoshop, Illustrator, AutoCAD, Revit, 3ds Max, and so many more programs, either in the form of a PDF or the physical model you're making itself. That information can be transferred to another program. So one way what I normally did in architecture school is, let's say I designed something and I want to, create an entourage, apply materials, all these things. I can do a rendering, but let's say it's a 2D drawing, right? You can turn this 3D object into a 2D drawing and then take that information and transfer it to Photoshop or Illustrator. And I'm going to demonstrate how you do that. So let's highlight this, and we're going to use a command called make 2D. So when you use make 2D, what's very important is to consider what viewport you're using make 2D in, because make 2D is going to create a two-dimensional outline of what your 3D model is from that perspective. So if I did make 2D of this from the top, it's going to look different from the make 2D from the perspective view. So let's hit OK. We don't have to worry about these settings, the tangent lines. And if we go to the top view, we can see a two-dimensional outline output of what we just made. But if I was to do this from the top view and hit make 2D, we don't want hidden lines, we don't want any of this, just a basic make 2D. You see, it's completely different from doing it from my perspective view. Even if I was to orbit a bit and do make 2D, it will always come out different based on what my current view position is. So just because you made a make 2D of a 2D model, it doesn't mean this is the end. You can always go back in, clean it up, join certain lines. I'm gonna make a future video talking about the workflow going from Rhino to a program like Photoshop or Illustrator to do further entourages and to liven up your drawings. We can even go in here, delete some of these objects. These lines will basically be invisible. If this is like solid, it'll be invisible. You could go in there, just clean it up a bit. EXT, END for extend. You can extend some of these lines. So there you have it. Those are 6/7 tools that you can use in Rhino to really help you get started in creating awesome 3D models and many other things, which the possibilities, quite frankly, is limitless in Rhino. Stay tuned for future tutorials, which I'm going to get more in depth in the program, more in depth with some of these commands I've shown you, and show you some of the interesting things that you can produce with it. As a reminder, make sure you see my trailer, Voice for the Future, leave a comment, like, whatever you would like, and please share the video with friends and family. So I'll see you all in the next one.